Welcome back to the class of physics. My name is Gurinder Pal Singh. This is my fourth and last video of the chapter Force and Laws of Motion. My goal today is to help you understand the concepts of conservation of linear momentum and its applications. Students, before I start, I would like to share a quick story about me. Actually, students, when I was kid, and I vividly remember that when I was in class 5, I was watching a movie where when hero fired the gun, then there was a jerk on his hand, and I always thought that it was just an action scene of the movie. And during play with my friends, I always used that action with my toy gun. But when my class teacher in class 9 told me about the exact concept regarding the recoiling of gun, then I came to know that it was not the style or stunt, but actually there is a law of conservation of linear momentum behind it. So students, in this video we will discuss about it. This lecture is going to be so much interesting for you. So let's start. We will start with the topic Law of Conservation of Linear Momentum. Well students, we will derive the law of conservation of linear momentum from Newton's third law of motion. Along Newton's third law of motion, we will use Newton's second law of motion also. So students, consider two bodies A and B of masses ma and mb constituting an isolated system. Isolated system means no external unbalanced forces acting on them. Let the bodies are moving with velocities UA and UB respectively along a straight line in the same direction. Let UA is greater than UB. Students, if UA is greater than UB, then collision will happen. After collision, let these bodies move with velocities VA and VB respectively in the same direction. Before starting the derivation, let's recall the formulae of linear momentum, Newton's second law of motion, and Newton's third law of motion. Linear momentum is equals to mass into velocity. According to Newton's second law of motion, applied force is equals to rate of change of its linear momentum. It means F is equals to change in momentum upon time, and change in momentum can be calculated by subtracting initial momentum from final momentum. And according to Newton's third law of motion, action is equals to minus of reaction. Now my dear students, it will be very easy for you to understand this derivation. For body A, linear momentum of ball A before collision is equals to MAUA, and linear momentum of ball A after collision is equals to MAVA, and rate of change of its momentum during collision is equals to MA VA minus UA upon T, that is equals to F of AB. This is according to Newton's second law of motion. Similarly, for body B, linear momentum of ball B before collision is equals to MBUB, and linear momentum of ball B after collision is equals to MBVB, and rate of change of its momentum during collision is equals to MB VB minus UB upon T, that is equals to FBA. This is according to Newton's second law of motion. Now students, according to Newton's third law of motion, action is equals to minus of reaction, means F of AB is equals to minus F of BA. We will substitute the values of FAB and FBA. After substituting the values, T will be cancelled out. We will open the brackets, and then after simple rearranging the terms, we will get MAUA plus MBUB is equals to MAVA plus MBVB. That means total linear momentum before collision is equals to total linear momentum after collision. Students, this is the law of conservation of linear momentum. Now students, I'll discuss with you one example to illustrate the law of conservation of linear momentum. That example is a recoil of a gun. Dear students, do you know that why a gun recoils on firing? I'll explain you, so listen carefully. Well students, the gun and bullet in it forms a system. The system is at rest before firing. So, linear momentum of system before firing is 0. After firing, the bullet leaves the gun and it moves with a large velocity in the forward direction. Thus, the bullet has larger linear momentum. Since no net external force acts on the system, so its linear momentum after firing must also be zero. Students, this can happen if the gun has linear momentum equals to the magnitude of linear momentum of bullet and in the backward direction. Therefore, gun recoils to conserve the linear momentum. Students, the velocity with which a gun moves backward after firing a bullet is called recoil velocity. Let's understand this thing in detail with the expression for recoil velocity. Students, according to law of conservation of linear momentum of system before firing is equals to linear momentum of system after firing. Here system consists of gun and bullet. Let ma is equals to mass of gun and mb is equals to mass of bullet, where ua is the velocity of gun before firing and ub is the velocity of bullet before firing. Similarly, va is the velocity of gun after firing and vb is the velocity of bullet after firing. So accordingly, MAUA plus MBUB is equals to MAVA plus MBVB. We know that before firing, UA is 0 and UB is 0 because both gun and bullet are at rest. We will substitute the values and on simple rearranging, we will get minus MBVB is equals to MAVA, and on rearranging further, we will get VA is equals to minus MBVB upon MA. So students, this negative sign shows that the velocity of gun is in the opposite direction to that of velocity of bullet. And one more thing, recoil velocity of gun is inversely proportional to the mass of gun. This means that heavy gun recoils with small speed and light gun recoils with large speed. Students, there is one caution also. It is advised to hold the gun tightly against the shoulder. In this case, the recoil of gun doesn't hurt the shoulder. On the other hand, if the gun is loosely held against the shoulder, loosely held means there is a small gap between shoulder and gun, then gun will hit the shoulder with a large force during the firing. As a result, the shoulder would get hurt. Now students, we will do one numerical based on law of conservation of linear momentum. In this numerical, a bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of pistol? Students, let MA is the mass of gun or pistol that is equals to 2 kilograms. MB is equals to mass of bullet that is equals to 20 grams. Convert grams into kilograms. Let UA is velocity of gun before firing that is equals to 0. Let UB is the velocity of bullet before firing that is equals to 0. VA is the velocity of gun after firing. This is the recoil velocity which we have to calculate. VB is the velocity of bullet after firing that is equals to 150 meter per second. According to law of conservation of linear momentum before firing is equals to linear momentum after firing. It means MAUA plus MBUB is equals to MAVA plus MBVB. Now we will simply substitute the values. On rearranging the terms, we will get the value of VA, that is minus 1.5 meter per second. Negative sign indicates that the direction in which the pistol would recoil is opposite to that of the bullet. Now my dear students, one question for you. Question is, a bomb explodes in mid-air into two equal fragments. What is the direction of motion of two fragments? Think about it, students, think. Let me tell you. Actually, students, when a bomb explodes in mid-air into two equal fragments, then two equal fragments move in opposite directions to conserve the linear momentum. So students, this is the end of my fourth video of this chapter. Hope I am able to clear your all concepts related to law of conservation of linear momentum. Hope you have enjoyed this video lecture very much. Dear, practice your all numericals related to law of conservation of linear momentum. Thank you so much for watching this video. Goodbye.